Alright, this is section 4.1. We're going to start chapter 4. This is all about graphing and doing all of the things involving the graphs of trigonometric functions. So all 6 trig functions we have talked about, we are now going to graph. From past experience, this is what you could say is definitely the most intensive or difficult chapter that you will face in this class. So what I'm going to do basically is we're going to have almost 2 days per section, and what we're going to do is we're going to do the best we can to stay focused, to work hard, be resilient, and intend to succeed. I think all of us can be successful, but basically I just want you to emphasize and think and intend to succeed. Don't just go through motions of studying without intending on being a master of the material. Okay, so you're going to have to study, you're going to have to come into class, and we will work hard in order for you to understand exactly what we're looking for. Okay, so I don't necessarily put this on here to scare you in any way. I put that on there to let's motivate you, let's work hard. Okay, so with your graphing calculators, if you have one, put it in radian mode and enter the equation y equals sine of x. Okay, now if you have your blue sheet with you, there is a little bit of a picture on the blue sheet, but this is what the sine curve looks like. Okay, so if you put it in there, push graph, you can push zoom trig and it'll zoom it in a lot nicer way for you, and this is what's going to come up. What do you notice about the sine graph? What I'm hoping that you notice, now I don't really have time to pick your brain or anything, I'm hoping you notice that this thing kind of repeats. It's what we call a periodic or repeating wave action type graph. So it kind of looks like a wave, okay, or it repeats itself over and over and over again. Okay, hopefully you also notice that the regular parent function sine graph is restricted between two numbers. It's restricted between -1 to 1. That is its range. It's going to be restricted on its range from -1 to 1. So hopefully you kind of make sense of that. If you actually also look on the blue sheet with the pictures, the sine theta is sandwiched between. They tell you the range is from -1 to 1. So it's just kind of nice to have that on the blue sheet to have out if you need it. Okay, so how do I actually graph this thing? Well, this comes off your unit circle. If you guys take out your unit circle, or if we just do these calculations, what I'm going to do is I'm going to plug all of these values into my sine x function. So what is the sine of 0? What's the y value at 0? Well, we know that it's going to be 0. So what does that mean? At 0, we're here. So now notice on my x value I go from -1 to 1 because I know that's my range. And what I've done now is what we're going to do is graph one entire unit circle. So you guys agree that from 0 radians all the way to 2 pi would be one complete unit circle? We're going to go all the way around the circle and we're going to see what kind of graph that makes. And you're going to notice that it's going to be one full period. So let's keep going. What I'm going to do is I'm going to kind of jump to the ones that I think make it most sense to you. Pi over 2, that's straight up. What's the y value at pi over 2? Well, I know that it's 1. What's the y value at pi, or straight to the left at 180 degrees? I know that that's going to be 0. Okay, what's the y value straight down at 3 pi over 2? That's -1. And what's the y value back at 2 pi? 0. So basically where I'm going to end up going every single time is at pi over 2, I know I'm at 1. And I know that at pi I'm back at 0. And at 3 pi over 2 I'm at -1. And then all of a sudden I'm back at 0. And what's happening is, if you kind of look at this, you're going to notice that this thing takes a curved shape and then I start over. My period's done. I went through one cycle of the unit circle and then the unit circle repeats, and I could keep going with the same exact area. Now, why do I have all these in here? What I want to kind of emphasize is what happens. Everybody probably knows what sine of 45 degrees is. Okay, so if you kind of do your unit circle and make a 45-degree angle, it's the 1 square root of 2. So I know it ends up being root 2 over 2. Well, it's square root of 2 over 2 at pi over 4. 3 pi over 4 is in the second quadrant, same reference angle. Okay, and sine is positive, so I know that this one is also square root of 2 over 2. But what happens at 5 pi over 4? Now all of a sudden I have a 45-degree reference angle, but now I'm down, so it's going to be -1. So it's going to be negative root 2 over 2 And this one's also going to be negative root 2 over 2 in the fourth quadrant. So remember when I talked about how there's always two angles that make this true in the positive side and then two angles on the negative side? That shows up on our graph as well. Okay, square root of 2 over 2 happens at pi over 4 and 3 pi over 4. And you can kind of draw a line, and that's the two values that make that angle measurement, or that true. Okay, and then the two negative ones would be down here. And that's why there are two answers for a specific value. Okay, so that's where our graph kind of comes from. So what I want to get, or have you kind of think about through this, is this. All right, from 0 to 2 pi, our regular parent function, we have what I deem as four major significant points that we have to graph. Where we start, okay, is pretty obvious at 0, and then I need to go, where is it at its peak? Where is it back at 0? Where is it at its lowest peak or valley? And where do I start to repeat? And those become my significant points on my graph. So my normal period for a sine graph is 2 pi. Okay? Now what about a cosine graph? Alright, what do you guys think about cosine? Alright, if you type in cosine on your graph, this is what it looks like. Notice it still has the same wavy type action. Alright, so what do I notice? I'd say it still would have a wave action type thing. Notice its range is still between -1 and 1, except it doesn't start at the same spot. Instead of starting at 0 like the sine does and it goes like this, cosine starts at 1 above. So we'll talk about the significance of what the word cosine actually means. But here are the two graphs. So what you could do then, if you went into your unit circle, cosine at 0, what happens at 0? Okay, what's the x value at 0? It's at 1. Okay, and if you jump to pi over 2, what's cosine straight up? Okay, the x value straight up is 0. What's the cosine or the x value straight to the left? It's 1 down. Okay, it's -1. Cosine straight down would be, or the x value down is 0. And then I'm going to repeat. So there I'm at my same wave action, same idea. So what's important? What do we need to take out of these graphs? We need to know that the normal period for both of these two significant trig functions that we do, is 2 pi, or 1 unit circle. Okay? One trip around the circle, we get every possible coordinate point that we can get. Okay? So that's what you need to know. That's what period is. And then it starts to repeat itself. Okay, amplitude refers to your range, how much stretched, horrible English, horrible grammar. Anyway, how stretched out is it? It's going to be from -1 to 1 in both instances, unless the amplitude changes. Okay, amplitude is like the vertical stretch on any graph that you've ever done since Algebra 2 or in any other class you've had. Okay, so what I want to do on this slide is let's extend this a little bit. Can you graph it not only 1 time around the circle, but 2 times around the circle? Okay, so what I'm going to try reach for, want you to do is this. My amplitude's not changing, so it's going to be -1 to 1. Okay, going around the circle, the major critical values are at 0. Okay, and then what I did on the last ones was straight up, which is pi over 2. Straight to the left, straight down, and then where I start over. Okay, that's one cycle. So we went through and said for the sine curve, okay, sine of 0 is at 0. Sine, or the y value straight up's 1. The y value straight left is back at 0. The y value at straight to the left is -1. Or straight down is -1, I apologize. And then the y value back to where we start is at 2 pi. So this is one cycle. What I'm trying to push you to realize is this. If I go through 4 pi, that's meaning 2 cycles of my graph, or the period happening twice. So what you need to do is extend this farther. So I had 4 critical points after that, and they all differ by pi over 2. Okay, so I'm going to really push you to think about, if your period is 2 pi and I want to put 4 coordinate points on the graph, we're going to say that they are pi over 2 units apart. So if I start at 2 pi, or essentially that's 4 pi over 2, if I add another one, that's 5 pi over 2. Okay? If I add another one, that would be 6 pi over 2, but that's equal to 3 pi. If I add another one, that's 7 pi over 2. And the fourth one would be 8 pi over 2, which we're just going to say is your 4 pi. Now what happens to your sine curve? All this is doing is this becomes your start again, and then we need to repeat. So now at 5 pi over 2, we know that we're going to be, that's pi over 2 farther, so the y value is straight up at 1. 3 pi would be 1 full circle, and then another pi, which you're straight to the left. 7 pi over 2 means 1 full circle, and then you're ending up straight down. And then 4 pi is 2 entire trips around the unit circle, but you're back to home base. So now it just ends up being, notice that your sine curve repeats. Here's 1 trip around the unit circle. Here's the exact same trip around the unit circle a second time. Okay? What's different about cosine? It just starts in a different spot. Okay? So what we need to do is this. We start at 0. My first trip around the circle, since I know my period's 2 pi and I'm going to make 4 critical points after my starting spot, I'm going to say it's pi over 2 units apart. Pi over 2, pi, 3 pi over 2, 2 pi. Okay? But with cosine, where do I start? Okay, what is the cosine of 0 radians? What is the cosine straight to the right? What's the x value to the right? It's actually 1. Okay, so that's why I start at 1. Cosine straight up, the x value straight up is 0. The x value straight to the left is -1. X value straight down is 0. X value at home base again would be at 1. And then I'm going to recycle. So now, important things to realize, I don't know if you guys are watching or really paying attention to how I'm curving this. These things do not, it's not like connect the dots where you make straight jagged lines. It's a curve action. It's a wave. And you need to make the wave. Now I'm going to make 4 more dashes. Why? Because I need to cycle all the way to 4 pi. And this isn't going to change. It's going to be the same values as up here. So I'm going to add pi over 2 again. 3 pi. 7 pi over 2. 4 pi. And I'm just going to redo it. So this is like up, this is straight left, here's straight down, and here's back at home base. And you should have the same wave action. So that is sine and cosine going through the 4 pi measurements. Okay? So now what I want to do is let's cycle back and let's see if we can figure this out. Using your graphs from 4 and 5, so what we just got done doing, can we answer the following questions? So what I want to do is find all the values of x in which from 0 to 4 pi now is my answer, so I have a bunch more answers than what we kind of have ever done before. What angles give me the answer of 1/2? Okay, so 1/2 refers to this. Halfway in there. How many times does my graph hit that dashed line? Once here, and here, and here, and here. Now what does this mean? We have been ingrained or trained to only look at this first unit circle, 1 trip around the circle. And all of us can probably get that answer using our calculator. Okay? All of us can probably say, hey, if I take sine inverse of 1/2, okay, and if you put it in degree mode, you would get 30 degrees. Okay, so if I draw this, my reference angle is 30 degrees. Which means, where else is sine positive? Second quadrant. That's also 30 degrees. So my 2 answers would be 30 degrees, okay, and 150 degrees. The problem is, we want radians, so my 2 answers technically would be pi over 6, and I'm pi over 6 shy of pi, so that'd be 5 pi over 6. Okay, now all of us are like, yeah, that's pretty easy. Not bad, right? Well, we also, oh, I lied, have 2 more. Well, these things are symmetrical. How far apart are they? They're at the exact same spot on our graph, just how much farther? 1 period farther. They are 2 pi units farther, because it's just 1 trip, 1 more trip around the circle. Okay? If I would say this is just, hey, this is one trip around the circle, I need to go one trip, full trip, plus 30 degrees. So instead of saying 30 degrees and 150, my other two answers, which now I'm going to bump it to 4 possible answers, 2 answers in each period, I just need to add 2 pi to the 2 that are originally there. Now, in order to add 2 pi, you can't just add it unless you have a common denominator, so I would add 12 pi over 6, which is the same as 2 pi. So my other two answers would be 13 pi over 6, okay, and 17 pi over 6 in order to find those 4, now it's 4 possible answers because we are going 2 periods, 2 cycles, 2 answers for each period. Now what I'm going to try to do is try to go a little bit quicker here. So if I look at cosine, where's negative root 2 over 2? Alright, now in order to do this, you're probably going to want to do your cosine inverse. What is the cosine inverse of negative root 2 over 2? Seeing negative root 2 over 2, you probably should see, hey, that's going to be a 45-degree angle of some sort. Since it's negative, I know I'm going to be left. Okay? So now when you do this in your calculator is going to give you 135 degrees. Okay? Which is going to be your 3 pi over 4. Now how do I get the other one? Since I know my reference angle needs to be 45 degrees, if my calculator gives 135, this one also is 45 degrees. So my 2 original answers that all of us probably could have received anyway would be 3 pi over 4 and 5 pi over 4. Okay? Now on your graph, what would this look like? I'm looking for negative root 2 over 2, which is somewhere in there. You'll get an answer here, here, and then your second flip through, you'll get those 2 answers. So graphically, that's where we're going. It's between pi over 2 and pi, and between pi and 3 pi over 2, which that is quadrant 2 and quadrant 3. But how do I get the other 2? Remember, this is periodic. It repeats itself. I cannot emphasize that enough. So go 2 pi units, one more full trip around the circle from where we're at. So just like the sine one, you can add 2 pi, which is like 12 pi over 6. So if I add 12, I lied, it's got to be over 4. I don't know why I'm thinking that now. So what we want to do is do 8 pi over 4, not 12 pi over 6. We want to add 8 pi over 4. I apologize, because that would reduce to 2 pi, and that is really ugly, but bear with me. So 3 pi over 4 plus 8 pi over 4, the other answer would be 11 pi over 4. And also then 8 plus 5 would be 13 pi over 4. And that's how you would get your 4 answers for those problems. Okay? The last one, the one I did not look at. Cosecant x equals 1. Now I have not done this before. What's that related to? What's cosecant related to? I'm not even going to do the graph. If I flip this, okay, the only way I can get cosecant that relates to sine x, and that would be that just flipping it. Well, it just happens to be the same. So cosecant and sine share this coordinate point. Where is sine x equal to 1 between 0 and 4 pi? Alright, where are we at 1? At that coordinate point, and then 1 full period over. It only happens 1 time. So where is sine 1? Where's the y value at 1? At pi over 2. And then it should be 2 pi units farther. So at 5 pi over 2. Alright, so my answer would be pi over 2 and 5 pi over 2. Okay, so that's another quick example that we can look for. So the tangent and cotangent problems. That's the last ones we are looking at. So, if you put this in your calculator, I'm going to ask you, is this graph as periodic as the others? And the answer should definitely be no. Okay? So what you really want to think about is, why is it no? If you look at your calculator, that looks like absolutely craziness. Okay? Now it's not periodic because periodic means you can graph it without lifting up your pencil. Well, I can graph this part, but then I got to lift it to get to the next part. What happens is these are asymptotes in the middle. Okay? So is the graph periodic? Absolutely not. Okay, what is the period? How far apart is a period for tangent? So what we need to think about with the tangent equation is this. Where do we run into problems? And what you got to think about is, and I'm going to show you how to graph this, is tangent is y over x. So basically when x is 0, we have a problem. And so what we need to kind of think about is, excuse me, on a unit circle, if we do y over x, where is x 0 on a unit circle? X is 0 straight up and straight down. That becomes our major issue. Okay? So here's what we want to do. Kind of like we did before. If I start at 0 and then I go pi over 2, my major critical values are straight up, straight left, straight down, and straight right. And what I'm going to do is actually go backwards. Negative pi over 2, pi, 3 pi over 2, 2 pi, all in the negative direction. The reason I'm doing this is for a reason. Straight up, I said we have a problem because that's where x is 0. So that'd be 1 over 0. That becomes undefined. So I have an asymptote at pi over 2. I also have an asymptote straight down. So if I actually start at 0 and go down, that's negative pi over 2. I have an asymptote. This is going to become the area that we zoom in on for tangent. And this is what the tangent graph looks like. And we'll talk more about this in class. Okay? But at 0, okay, that means that y is 0, the x is 1, it's at 0. We are restricted in here. So if I go back and say, hey, is this graph periodic? What's its period? How long does it take to go through one cycle? Or how far is it from one asymptote to the other? Negative pi over 2 to pi over 2. My period for tangent is pi. Okay, instead of 2 pi, it is just pi. And what it ends up doing is it'll repeat itself. So the next one, 3 pi over 2, that's straight down. If you actually go the positive direction, that's a problem. So it's going to run right in here, just like that. And so on and so forth. And it's going to repeat itself over and over and over again. It does repeat. Okay, it is technically periodic, but problem is it's not a consistent periodic problem. You're not going to be able to continuously do this without lifting up your pencil. Okay, so your period would end up being pi. All right, so that's what we need to really strive to understand. Okay, cotangent is just going to be the reciprocal. Remember, cotangent ends up being what? X over y. So where is there problems with the y? Where is y equal to 0? Okay, y is equal to 0 at 0 and at pi. So instead of your asymptotes being at pi over 2 and negative pi over 2 and 3 pi over 2, your asymptotes are going to be at 0. And I'm going to put those exact same critical points that we have used the whole time. Okay? And where do we run into problems? At 0. Okay, that's a problem. And then we run into problems at pi, because that's where we are straight left. Or we could run into problems at negative pi. Either way, notice there are still asymptotes, except we need to figure out which way this thing travels. We said that these things are reciprocals in a way, so everything needs to kind of flip-flop. Alright? So it's still going to be 0 here, except we're going to go down. And I'll kind of go through this more in depth in class as to why this happens. But the cotangent goes down, tangent goes up. Everything's just flip-flopped or reflected because they are reciprocals. Alright? So here we go. We are going to try sketch cosine. You know what? We're going to do this one in class. It'll just be easier that way. So try to do cosine left and right. I'm going to kind of do that one in class for you. Okay, on third thought, I'm actually going to do this problem. I wasn't going to, but I'm going to. So, to graph cosine from negative 4 pi to 4 pi, this is going to get kind of crazy and obnoxious. But what we talked about was, where does cosine start? And I already did it wrong. Okay. Remember, there are 4 critical points for every period that we go through. So with cosine at 0, I'm going to start that at 1. So I need to establish where is my 1 and negative 1 on my graph. So I'm going to say that's 1, that's negative 1. Cosine starts at 1. and I said there are 4 important points after that. Where are we at? Straight up on the unit circle, straight to the left, straight down, back at home base, and then I got to do it again. So, and I'm going to go off the page, but hopefully you guys do a better job of that. Okay, so I know that my period for cosine is 2 pi, and if per period I'm going to go pi over 2 units apart. So pi over 2, then pi is straight left, 3 pi over 2 down, 2 pi, and then I'm going to cycle through one more time going pi over 2 apart. So I'm going to be at 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, and now what do we do? You can kind of almost go step by step through. So at 0, my x value is 1. Straight up, my x value is 0. Left, it's at -1, and so on down the line until we repeat. So there's one cycle. The problem is I have to go to 4 pi. So now I'm going to go back down. 0, -1, 0, 1. And you can't see that because blue's on blue, but you know what? That's the way it goes. Okay? And then if I ask you to go to -4 pi, you have to go backwards. Now, that's not necessarily simple, but it's literally a mirror image of what we just got done doing. And those are not necessarily part, but basically you can rewrite what you did in the exact reverse order, because you're just going backwards on the unit circle. And none of that's changing. I'm actually going to just jump to -3 pi, -4 pi to save time. Okay? So now instead of this, negative pi over 2 is just saying, hey, I am pi over 2 units or straight down. My x value is 0. Negative pi is straight left, so you're down. And then you're just going to keep the cycle going as long as you do those main critical values. And we'll talk about that more as we practice this in class, graphing these things in various periods. Okay, so this thing should be continuous periodic wave action. Okay, the first crazy one that we're going to look at is secant, and we'll do cosecant in class. But basically what you need to do is sketch the reciprocal first. That's the easiest thing to do. So secant is related to cosine. We just got done graphing cosine in a variety, 100,000 different ways. So I know that 1, -1, cosine starts at 1, and your 4 critical, okay? So that's pi over 2, pi, 3 pi over 2, 2 pi. Alright, so there's your reciprocal if you want to think about that. Now, what happens to actually graph the one we want? What happens at these coordinate points? So, at 1, okay, is that going to change at all? Think about it. At secant at 0, okay, is 1. If you flip 1, it's still 1 over 1. That doesn't change. What changes, what's important, are these coordinate points that are at 0. Because if at pi over 2, cosine is 1 over 0, if I flip it, the secant's going to be 1 over 0. That's undefined. That's a problem. So we are going to end up with asymptotes on secants and cosecants on any of the values that are at 0 on the original picture. Okay? And then everything else is a reciprocal. So we share this point, but as cosine, I said, kind of flew through here, this point is going to flip. So let's say the 1/2, wherever it's at 1/2, it's going to flip to 2 over 1. So instead of being here, it's going to go up here. And it's going to take a shape and get close to your asymptote, but never reach it. And all that's going to end up happening is it's going to share this point, and they're actually never going to be between -1 and 1. They're always going to be above 1 or below 1. And that's going to be the exact same for secant and also cosecant. But I'm not going to waste any more of your time showing you that. We'll just do more as we move on in class. So I hope this didn't get too crazy.